Alright, 1, it asks you, given this equation and the domain of this, to find the range. So you could have done this one of two ways. By hand or in your calculator. I'm just going to do it in your calculator. So in your calculator, go to your y equals, put in that equation. Go to your table. Oh, my table is off. I was like, why is it happening? Okay. Your table should look something like this. We're trying to find the range at 4 different numbers. -3, -2, 0, 3. So I'm going to scroll up to -3. So when x is -3, y is -2, that's one of your answers. When x is -2, y is 0, that's another. When x is 0, y is 4. And when x is 3, y is 10. So -2, 0, 4, 10 is your answer there. If you were doing this by hand, you would take each one of those x's, put them into your equation, and solve for y. So 2 times -3 is -6. -6 plus 4.
Oh, wait, no.
It is a negative.
Yeah.
-2.
I'll do that.
2 times -2.
-4.
-4. And then -4 plus 4 is 0. 2 times 0. 0. So this was just 4. 2 times 3. 6, and then 6 plus 4, 10. So you could have done that either way, but when it gives you an equation like that and it gives you a list of numbers and asks you to find either the domain or the range, that's what you're doing. Putting it back in, solving, or putting it into the calculator, looking for the other. Okay? Make sure you have that answer written down, and then pass up your answer sheets. Be careful when you're passing them up so it doesn't rip off the graph.
Okay.
I know I gave you guys homework last class, but we're not going to check that today because I want to make sure you're ready for the quarter test.
When is that? Okay.
Yes. No. Today's Monday. It'll be Wednesday.
It's Wednesday?
Yes. That's why we're going to review today.
That is literally over That's what I'm saying. They're probably lots of
Did you guys pass yours over? Do I have everyone's answer sheet? Okay, so we're gonna start this and then we'll finish after lunch. Does everyone have the quarter review that I passed out? That I did not pass it out to anybody. One of you guys is on the floor. objectives that we are retesting on this quarter test. So all of Unit 3, so that's finding your slope, graphing lines, and then your transformations of lines. And then Unit 4, the one we just tested right before break. So some of you still have not done that, which means you need to come see me today to take it. Otherwise, this is just going to replace the 0 that you have. And then you won't take it. So Unit 4, writing equations of lines, writing equations of parallel and perpendicular lines. And then the other objective is your line of best fit. So those of you that never took that also need to take that today. Otherwise, this is just going to replace the 0 you have. So for your slope, you need to be able to find your slope from your graph. Remember that these are always, so I'm going to write notes off to the side. These are always your y's over your x's, and rise over your run. If you're doing it in this format, and you can do that here too, it's y2 minus y1 over x2 minus x1. So you have to have your y's in your numerator, your x's in your denominator. Doesn't matter if you switch these two as long as you switch both. So whatever number it is, it should match the x's in this column. If there are points on the line, you can look for those two and count. If there are not points, find 2 points that cross the points exact, or 2 lines exactly. Those would be the only 2 in this case, and count from there. Does not matter if you start here and go that way or start here and go this way. What would your slope of this be?
-2 over -7.
So you're going down 2, so that's negative. But then you're going right, and that's positive. So it's not -2 over -7, but just -2/7. If you were going the other way, same thing, except you'd be going up 2 and left 7, which would still make it -2/7. Remember that down and left are both negative, up and right are both positive. Thinking about that now, my right and your right are 2 different rights. Questions on that one? So we're not going to do every single problem, but we'll do both of these just because they're easy. Anytime you get horizontal or vertical lines somewhere, you should probably write poi bucks. What does poi tell us? Horizontal lines. 2 other things. Zero slope. Y equals. So horizontal line, 0 slope, y equals. So then Bucks tells us vertical line, undefined slope,
X.
and then x equals. Right? So for this one, is this a vertical line or horizontal?
Horizontal.
Horizontal. This is horizontal. So this is a horizontal line, which means it will have what type of slope?
0 slope.
0 slope.
But we were solving for y would be 4.
If you were writing the equation, it would be y equals
3. Oops.
But in this case, that's not what you're doing. So pay attention to what it's asking you. Is it asking for slope or is it asking for the equation? And this one is asking for slope, so I don't need y equals 3. 3 is also not your slope. This one is then a horizontal line or a vertical line? Vertical. So what is our slope?
Undefined.
Undefined. It is not asking what the equation is, which would be x equals -1. -1 is not your slope. So make sure you keep that in mind. Alright. We're going to do one of these together, and I'll let you guys do the other one. Which one of those do you want to do together?
4.
4. Okay. So for 4, if we're using this, label it if that helps you. And then we're going to do 9 minus 9 over 4 minus -3. Remember that you're always subtracting, but if you have a negative and you're subtracting, they become positive. Or if you're adding. 9 minus 9 is 0. 4 minus -3 is positive 7, because you're adding. What is the slope actually? 0. What if it was the opposite? What if the 9s were in the denominator? It would be undefined. So, I said if the 9s were in the denominator, which means it would switch. Anytime you have a number over 0, that's going to be undefined. So if you get something like this or something like this, I expect the answer to be 0 or undefined. Don't leave it as that fraction. You can if it's not one of these fractions. So if it's like 1/2, yes. But if it's one of these, leave it as 0 or undefined. Alright, you guys can go get your... Alright, so we're going to do one of these and one of these. Let's do 7. You do number 6 as well. You start.
I'll give you 7 because it's easier.
Okay. I mean, they're both easy. What's the slope for 6? -1/2.
Oh wow, look, great teaching.
Because it told you the slope.
Oh, never mind. We should have done number 6.
Number 3.
But for 7, anytime you get an x equals a number or a y equals a number, just you have to think toy bucks.
Literally 0.
So your answer is going to be 0 or undefined, depending on what it's asking. These are both very similar. Yes.
Can I have a ruler?
Let's do 9 just because of that negative. So for each of these, we need to solve this, get this in slope-intercept form first before we do anything else, or before we can say our slope. So how do we get this in slope-intercept form?
Get rid of the x.
Get rid of the x by subtracting. Yes.
Divide everything by -3.
Okay. Notice that I also switched the places. So here, this matters. It matters whether x comes first or not. Because if x comes first, then it's in slope-intercept form. Remember, you're dividing each piece by -3. So when you divide this is really the same thing as positive 1/3x or x over 3, either one of those. This becomes -1. So what is your slope? 1/3.
let the slope be 3.
I think I was still in one word. Do like half actually. Because you have to subtract 3x and divide by 6. Alright, we're going to do one of each type of these. So your second objective, graphing your lines. Most of these are straightforward. If they give you points, or an x-intercept and a y-intercept, or 2 points, graph those 2 points, graph your line. So for 10, your x-intercept of -2 would be on your x-axis at -2. Your y-intercept would be on your y-axis at 3. And then you would draw a line in between both of them. Make sure these have arrows because these lines continue on forever and ever. If you need a ruler, I think the only reason if you got these wrong is because you switched them. You put the x-intercept at the y-intercept and vice versa. So don't do that. Okay, we're going to do 13. So plot those 2 points. Make sure you're doing x, y, x, y. So over 3, down to -1. Left 2, down to -3. And then draw a line in between those 2 points. And include arrows. You want to do 14 or 15? 15. I heard 15. Okay. For 15. If we're given a slope and a y-intercept, where are we starting? The y-intercept, so start at -4, and then you're using your slope of -2 over 3. So it's negative. What directions could make this negative? Left. So if I go left, I would, what direction, up or down? Down. Can I go down and left and it still be negative? No, because those are 2 negatives. 2 negatives make positive. So what direction would I have had to go if I went left? Up. So I can go up 2 and left 3. In this case, I can't go down and right, down 2 and right 3 because I can't go down 2.
Can't you go up 2 and left 3? Or right 3?
From right here. Because I can't go left 3 again. So do as much as you can until you run out of space. So you're always going up or down first. So up 2, left 3. If you went up 3 and left 2, that would be the incorrect slope. Alright, we're going to do 17, since this one's very similar to that one. We need to start at our y-intercept, which is what? -1. And then we need a slope of -3. Remember, all whole numbers have a 1 underneath it, so it's still in a fraction form. And then we are using those same directions, going up and going to the left, or going down and going to the right. So go up 3 and left 1 as much as you can. And then go down 3 from your y-intercept and right 1 as much as you can. And then make your line. There are 2 more graphing examples we're going to do. We'll do one of these and one of these. Which 2 do we want to do?
18
Okay.
and 21.
So I said one of these and then one of these.
18 and 19.
Okay. Can we graph 18 as is? No. So we need to do one of 2 things. I don't care how you graph this. You can either solve this for y by subtracting 4, dividing by 5. I'm going to do both. That's why I said that. So subtract 4x on both sides, divide everything by 5. So -4 this x plus 4 to get it in sloped intercept form. Or you can solve for your x and y intercept by covering up one term, setting the other term equal to whatever it equals. So 5y equals 20, what's y? 4. Covering up this term, 4x equals 20, what's x? 5. You can graph those 2 points and make a line, or you can use this and make your line. In this case, I think they both end up at the same place. That doesn't always happen. If I went down 4 and right 5, I'd end up at the same place. So in this case, they both ended up at the same place. Remember that this method doesn't always work because the numbers have to be divisible. If the numbers aren't divisible, that method doesn't work. Questions on that one? What are we going to use to graph 19?
X-axis.
What are we going to use to determine direction, slope? What? Poivus, yes. So what type of line will this be?
Vertical.
Vertical,
Undefined X.
because it's an x equals. So it's going to be a vertical at -3. So on the x-axis at -3. Your next objective was the one with transformations. So we need to remember 2 things. Anytime it deals with steeper or steepness, that's your slope changing. Anytime it deals with shifting up or down, that's your y-intercept changing. So if this is saying your function moved, it was subtracted by 3. what is that really saying? Did it become steeper? Did it shift?
Divided. Or subtracted by.
It was subtracted by 3, but what does that mean?
It was shifted down.
It was shifted down
3.
You can put 3 if you would like. So that means I'm going to take the entire function and move it down 3. Wherever this function was, I'm going to move each point down 3. Did your slope change? No. And that's because this was shifted down. Anytime it's shifted down, your y-intercept changes, not your slope. So that's not something we have to write there. It's just something to keep in mind, that your y-intercept changed, not your slope. Now for this one, what changed? What is going to change?
Steepness.
The steepness. Because it's multiplying. Anytime it's multiplying, your steepness changes. Now, would this be less steep or steeper? Less steep. Remember, anytime that it's a fraction that's less than 1, so the numerator is less than the denominator, it will be less steep. To find your new graph, your original slope was 1, and now you're going to multiply it by 1/2. So your y-intercept is not changing, but now you're going to go up 1, right 2. Instead of up 1, right 1. And down 1, left 2. Instead of up or down 1, left 1.
And I think that's how you got
The graph.
Yeah.
Because of this, it's telling us that's our new slope. Our slope was 1. So from multiplying our slope by 1/2, it's now 1/2. So I'm going up 1 over 2. Up 1 over 2.
Oh.
So in this case, our slope changed, but our y-intercept did not. So that's just a side note. And number 3, we're comparing whatever the original was, so that's the black line up here, to this new function. Was our new function shifted up or down from our original?
Up.
Up. How do you know that?
This is plus.
Because of the y-intercept. It changed. It's now up. Because it was at 0. Is this steeper or less steep? Is it a fraction?
Steep now.
No. So even though it's negative, that doesn't make it less steep. It's still steeper because of the 5. If it was, you could graph it. So you could put this and this into your y equals. I'm going to do that really fast. So the blue is your original, the red is your new graph. Which one, if you were skiing or sledding or whatever, which one would you get down faster?
The red.
The red. So the red one's steeper.
Okay, so to know if it's like up or down, if it's like positive, it's up, if it's negative, it's down.
For shifted?
Yeah.
Yes.
And what about for steeper and less steep?
You have to look at your slope. Is your slope bigger than 1 or is it less than 1?
Like bigger than one.
Yes. Even though it's negative, I'm not looking at that.
Oh.
So now 4 is comparing your original, so I'm going to draw that on here. Your original is this graph right here. You don't have to graph this, but you can if it helps. That was a little crooked. It's comparing that line that I just drew in to the line that was already there. What is the slope of this line in red? 4. So if we're comparing the slope of the line in red and the slope of the line in blue, we know it's 4. What was the slope of the line in blue? 1. So we're comparing, how did we get from 1 to 4? Did we add 1 plus 4 and get 4? Is 1 plus 4 4? No. Did we subtract 4 from 1 to get 4? No. Did we divide by 4 to get 4? So we had to multiply. 4 times 1.
Wait, how did you graph it? Like, how did you graph it?
How do you even find that?
This has a slope of 1, y-intercept of 0. So we just graph that line. What did you say? The second question is comparing the y-intercepts. What's your y-intercept of the blue line? 0. What's your y-intercept of the red line?
-2.
-2. So now we are comparing 0 and -2. What did we do to get from 0 to -2?
Subtract.
We subtracted. For your y-intercepts, you're always going to add or subtract. For your slope, you're always going to multiply and divide. Now for this one, it's telling you to do both. It's telling you to take the original graph, and it wants you to shift it down 2 units, and it wants it to be 3 times as steep. How is that going to help us find new points? What does that tell us about our new graph? Ian.
Down to the right 2.
It's moved down 2, so that's our new y-intercept. What was the second thing you said?
So left 3.
So it's not going to be moved left 3 times.
Oh.
It's not up either. 3 times as steep. What is that going to tell us? It's steeper. But what is steeper?
The line itself.
The line itself and our slope is going to be steeper. The steepness always tells you your slope. Shifting up or shifting down tells you your y-intercept. Now, this only wants us to find 2 points. It doesn't actually want us to make a whole new line. So what would one of these points be
-2.
as an ordered pair? 0, -2 would be your y-intercept. How would we find another point? Yeah.
Down 1 to the right 3.
Sorry, say that one more time.
Down 1 to the right 3.
do the opposite. So down 3
The right one.
to the left one, or you can go up 3 to the right one. Since your slope is 3. Either of those points would be fine. You can go up 3, right 1. What is that? 1, 1?
Yep.
Or you could go down 3, left 1. So -1, -5.
Well, we get iPads on the best.
For the line of best fit? Yes. But you only need 2 points. I know this section was like the most missed, so do we have questions on anything? Yes.
I'm confused on how the blue works.
The blue is your slope. So
Which one is it? One
you can use either. Does not matter.
How does it find it?
If you're starting at your y-intercept, just like when we were graphing, start at your y-intercept, use your slope. Go up 3, right 1. Or down 3, left 1. Yes.
So wait, what do you mean by the original column? Is it the column that was on 3 that you compared it to?
So each of these originals is this line right here,
Okay.
or this function right here.
So you figured out the blue line for that one.
For
That
which
one.
one? For which one?
For number 4, right?
Noise.
So the blue line was the original, yes.
Wait, how did you find it?
This sounds good to me, though.
This will be your slope. Anytime it's talking about steepness, that's your slope.
No, the other kind of Christmas bells.
Alright, right now, does anyone want an iPad 4 line of best bet?
Yes.
Okay, just keep your hands raised for a second.
Well, you can also find it on the calculator, right?
Yes, you can also do it on the calculator. So we'll do one of these on both. Sure, we can do one. Alright, so in Desmos, remember you're going to add this plus, go into your table, and then add your age and months in the X column, your weight in the Y column. If you're doing it on your calculator, you need to go into Stat, go into Edit, put your age and months in L1, your weight in L2. Stat, edit. I have stuff in my list, so I'm going to go up to the top and press clear. Remember, don't press delete or you'll get rid of it completely. So back to Desmos. After you have this, in your next line, you're going to type the following. Y1, Y, and then just the number 1. You need to find your tilde.
Why have you told me this?
There we go. The symbol that looks like this. So if you're in this
Is it X1? That's
MX1. If you go into ABC, your tilde is right here.
And don't reduce plus B1,
MX1,
and plus B1,
then plus B.
just plus B.
Yes.
Okay.
So Y1 tilde MX1 plus B. And you're given your slope and your y-intercept for your line of best fit.
I haven't done one best fit.
It also graphs it for you. You can find those points by zooming in and zooming out on Desmos. Let me do this part on the calculator first before I continue. After you have this in your calculator, you're going to go stat, calculate, and you need this one, linear regression number 4. Make sure that X list is in L1, the Y list is in L2. Store it.
Wait, what happens after you go into under calc?
Number 4. Store it as alpha trace. One of these equations, doesn't matter which one. And then calculate. You should get the same numbers that we have in Desmos. I'm going to split screen this. 0.669, 9.32. When it's asking for your line of best fit, if it says specifically to round, you need to round. Otherwise, you could put all the decimals. You could just put 1 decimal. It's really up to you if it does not say. For this one, I'm just going to put 0.7 plus 9.3. I'm going to use 1 decimal after the actual thing. So y equals 0.7x plus 9.3. If you use 2 decimals, that's fine. If you use all of them, that's fine. Use at least 1. Ian.
Mine don't work. It's like a flat line.
Does it... You're on Desmos, right?
Yeah.
Does yours look exactly like this? Your equation?
And I have like a line on the side.
I'd have to say it. The next part about predicting, we need to predict the weight of a 30-month and a 4-year-old boy.
I figured it out.
So if you're good.
Yeah, it's close to
Oh, well, that's...
I think
To predict the weight of the 30-month.
Would you put another table?
Yes, so on Desmos, in another empty space, first put your equation that we just wrote down, y equals, put this over here, 0.7x plus 9.3. And then go into your wheel, your settings. Next to that equation is a table. Click that table,
Go to 30.
and then you're going to type in the number 30. So at the bottom of your X's, type in the number 30, and that's going to give you the answer to the weight of the 30-month-old boy. 30-month-old boy. 30.3. And you have to think about whether, or realistically, can weight be decimals?
Yes.
Yes, so we can leave this as a decimal, 30.3.
Did you do 12 times 4?
To get
Yeah.
your number, yes, you would do 4 times 12, which is
42.0. Oh, 48.
48. So you would put 48 back into your table to find the next one.
42.9.
42.9.
Wait, why are we multiplying by 12?
Because this one says a 4-year-old boy, and it needs to be in months. In your calculator, because we stored this equation, it's going to look a little different. That's okay. Go back to your table, and instead of scrolling all the way down to 30 and 48, go to second window. It should say table set at the top. Change table start to whatever number you need. So 30. Go to your table. Now these numbers are a little off because we changed the equation. We rounded it. And that's okay. If I went back in and changed it to exactly what we have on our paper, the answers would match. And you could do the same thing for the year. Go back to your table set, change that to 48, and go back to your table to find the other weight. I'm going to leave the answers as that because we rounded. But if you're using your calculator and your answers are a little different, that's okay. Yes. As soon as Nisi gets back. Remember that anytime I ask for linear regression, that is the same thing as line of best fit, so don't get confused by that wording. Also, there was, like in this one. Sometimes it will switch what it's asking for. So in this case, we're looking for y. But if it asks for x, you'd have to solve for it. Questions on our line of best fit stuff?
After you put it in this table, you could put it in.
I'm calculating this is where it gets okay. This here. One of those. Stick any of them.
On to the next. So we'll do one of these and then move forward. Do we want to do 1 or 2 and then 3 or 4? Two and then 3 or 4. It doesn't matter. Alright, for number 2, if you're given a graph like this, and now we're in the writing equations, you need to know what your slope and your y-intercept is. We know this is going to be y equals, what's your slope? For number 2. Negative 2 over 4. Can that be reduced?
Yeah, maybe.
To negative 1/2. So anytime it can be reduced, do that. What that really means is if I go up 1 and left 2, there would be another point. What's your y-intercept?
-4.
Negative.
No.
Negative 3. So y equals negative 1/2 x minus 3.
Wait, we're doing minus 3.
That's your y-intercept.
Oh, okay. Do we get any problems where it's like the wires isn't like directly on the line?
No. For 3, how are we going to write this equation? What do we need in order to write this equation?
Holy buck.
$40. Is this a horizontal or vertical line?
Bird.
Vertical. So if it's a vertical line, is this x equals or y equals? X equals. What does x equal?
X equals 3.
That's the slope. 3.
Yeah, I said 3.
So when I said that was the slope, I was talking to Ariana. Okay, so pay attention to what it's asking you to find. Some of them want slope, some of them want you to graph it, some of them want the equation. All of them don't want the same thing. Now, these, we need to find the equation, which means we'll need to find the slope for some of them, and then find our y-intercept. So, we're going to do, we can do 1 or 2 of these, and then 1 or 2 of these.
6.
Okay.
Number 5 as well.
Okay.
9.
If we need to do another one of these, we can. So let's do these 3 first. If you're given 1 point in order pair and your slope, what are we missing? In our equation, y equals mx plus b, what are we missing?
Y.
The y-intercept. So we need to find our b. Put each of these in to your equation. Y is 3, m is 1/2, x is 2. We are solving for b. What's 1/2 times 2? 1.
So would the y-intercept be 2?
2, yes. Because you would subtract 1. Now, just because you find your y-intercept doesn't mean you're done. You need to put all of that together in an equation. What is your equation?
Y equals 1/2 x plus 2.
Correct. Don't forget your x's and y's. All of your equations need to be y equals whatever your slope is, the variable x, plus or minus whatever your y-intercept is. Be careful with problems like this. It's solved very much the same way, except what type of equations have a slope of 0?
0.
That's not incorrect. That's just not what I was looking for. Straight lines have 0 slopes. Which type of straight line has a 0 slope?
Y.
Y equals horizontal. So if this has to be a y equals, well, what does y equal? 9. Could you do the same thing? Yes. Except what's going to happen is the middle kind of cancels itself out. Because you end up with 9 equals 0 times 5 plus b, where 9 is b. If you put your equation together, 0 times anything is 0, so that wouldn't make sense to keep that there.
So the answer is just y equals 9.
That is your answer. Yeah.
In a situation, if it was like undefined, would it be y equals 5?
For undefined, is that x equals or y equals?
It would be x equals, right?
So it'd be x equals whatever x equals.
Okay.
7 is going to be solved very similar. The process is very similar. It just says vertical line, so you have to think about what type of line that will be. For 9, they don't give you anything except for 2 points. That means you need to find your slope, find your y-intercept. So let's find our slope first.
Is y2 minus
So y2 minus y1, 0 minus negative 2
Plus 2.
is really what you're doing, over 4 minus negative 4. So we have positive 2 in our denominator and
8.
8 in our denominator,
Which, that's 1/4.
which simplifies to 1/4.
So then,
So now we have m. We have 2 sets of x's and y's. Pick one and use it. I'm going to use the one with 0. So y is 0. 1/4 is my slope. 4 is my x. 1/4 times 4 is
1.
1.
1 minus 0 negative 4. So
Correct.
y equals 1/4 x minus.
That would be your equation. Y equals 1/4 x minus 1. Do we want to do another one?
Sure.
Pick one.
10.
Okay. For 10, same thing. We need to get our slope first. So 7 minus 4 over 2 minus 2.
It's 0 in the bottom.
It is 0 in the denominator.
So we use it 0 slope then?
It's undefined. It's undefined.
X equals 0.
So if it's undefined, that means it has to be at x equals, because of toy bucks. What does x equal? 2. Looking at both of your ordered pairs, x equals 2.
What are their different numbers? Can you just like choose between them?
If they were different, this wouldn't have worked out like this.
Oh.
So if they're the same, then whatever number it is. Last section. The writing equations that are parallel and perpendicular. For parallel lines, what do we know about the slopes?
What's this section?
The slopes are the same.
The slopes are the same, the y-intercepts are different. What do we know about perpendicular lines?
They cross.
They do cross.
And they become the negative, like you negative.
The negative reciprocals. The slopes are the negative reciprocals. So let's do one of these. Because this is just determining, are they parallel, perpendicular, or neither? Okay, we can do one. So for one, we need to find the slope of both of these equations. So that would be 2 minus negative 4 over 18 minus negative 6. 2 minus negative 4 is,
2 plus
which is
6.
18 minus negative 6,
Plus 6.
which is 24. Can this be simplified?
Yes.
To what? Okay. Now we need to find the slope of the other one. So negative 4 minus 8 over 10 minus 7. Negative 4 minus 8, negative 12. And then 10 minus 7 is 3. Can this be simplified? Yes. So negative 4. Are these parallel, perpendicular, or neither?
Perpendicular.
Perpendicular. How do we know that?
Does it have to be negative?
One of them has to be negative.
Because
There
there
is-
is force and one underneath it.
They're reciprocals, and one of them is negative. So these are perpendicular. Remember the upside down T means perpendicular. If you're doing the other symbols, 2 lines means parallel, not an 11.
How do you know if it's parallel?
The slopes have to be exactly the same. The y-intercepts have to be different. Alright. Let's do one that's parallel, one that's perpendicular, and if we need to do another, we'll do that if we have time. Let's do the most complicated ones. 5 and 7. Alright, so in order to determine our slope, because that's our first step, find our slope, we need to rearrange this by adding 3x. I'm sorry, subtracting 3x, I don't know why I said adding. And dividing each piece by -2. So that's not our answer. It just helped us find the slope we were looking for. We now know our slope is 3/2 of this line. If our new equation has to be parallel to this one, what will that slope be?
Y equals -3 over, no, y equals -2/3.
The slope will be 3/2.
Oh, I thought it said perpendicular.
Right, it would be negative if it was perpendicular. So now that we have our slope, we have a point, we have our slope, we're going to go back and we're going to find our b. So 4 equals 3/2 times -3 plus b. What does 3/2 times -3 equal? -4.5, because it'd be -9/2. If you have -9/2, that's fine. So if we add that to both sides, b is now,
Wait, is that a y or a 4?
this is a 4.
Is and the one above that is also a 4, or is that a y?
There's a 4.
So B equals 4.5.
Add 4.5 to both sides. I got 8.5. 8.5. Or 17.5. What would your equation then be?
Y
4
equals Y equals 3 over 2x plus
Or plus 17/2. Either one. So the process is the same. There's just extra steps. Okay, let's do a perpendicular one. Same thing. We need to solve this before we do anything else. So let's add x. And divide each by 3. That's not our answer. But if we need to write a new equation that is perpendicular to this one, what will our new slope be? -3. So this is where a lot of mess ups happen on that test because we weren't doing this piece. Now that we have our new slope, we have a point, we have a slope, we can now find b. 2 equals -3 times -5 plus b. -3 times -5, positive 15. What is b? -13. So what is our equation? Correct. So you are putting your new slope in, not your original, with your new y-intercept, not your original.
How'd you get 13?
Subtract 15 on both sides. Yes.
How'd you get 3 plus what? -3 plus
You have to take your negative reciprocal. Because it's perpendicular.
So you always take the body number.
Yes. Unless it's like 4/3 or something like that, then you need both numbers to split.
So you always take negative.
If this original slope was like this, your new slope would then be -3. So you have to use both numbers if they're like this. But if it's 1, you don't need both.
It always has to be a possibility to go. Ish.
Say that one more time.
So it always has to have the bigger number as well.
Not always. It depends on whatever the problem is. Alright. I do need to say one thing because earlier I was talking about the tests, if you were missing tests, and I said today. I'm not saying after today. I don't know why I said that. I meant tomorrow. Come see me tomorrow after school or before school. Or even before school Wednesday. But you need to come take that ASAP. Okay? Now, you do have some time left, so I would work on some of this review. The rest of this review needs to be done by Wednesday, because you're turning it in.
How much do you usually